So this really was a course. This really was a course. I hope now on categorization, communication, and consciousness. The feeling part was the consciousness, the hard problem. Communication in the end was everything that we did about the mirror neurons, as well as, of course, language. And categorization, I wanted to persuade you, was a lot more central and general and fundamental than we're accustomed to thinking of it. It's basically learning what to do with what, and to the extent that know-how is doing, most of it, it's not continuous movements. Pache Adriana's view that even some, pardon me? You want to change, what?
I'll just take it back forever.
Did you change your mind, or you're just trying to be nice? Okay. The reason I started off in emphasizing that this is about explanation is because it is. Cognitive science is not what we went into psychology for. It's not just a quest into our own minds and other minds and helping other people's minds. It's to figure out how our minds work, although we've now discovered that we're going to figure out how cognition works, but when it comes to the mind, it's going to end up being a hard problem. It turned out that introspection, oh my God, somebody's trying to Skype with me. Introspection, I can't, it's too late to turn it off. Introspection turned out not to be the way to do it because you couldn't figure out, it just didn't tell you anything. You just never found out how anything worked from introspection. And it always led to homunculus, that was basically doing the introspection that was in your head. I'm going to have to stop this and turn off the screen. I'm not quite this ditzy when I'm not standing in front of the class, when I'm thinking for myself. Okay. Right, is that?
That's going in my evaluation.
Okay. It's about observation, but of course observations don't speak for themselves. We talked about Descartes, and the reason Descartes was important was because he focused on what is really the essence of consciousness, which is this part that you can be absolutely sure about, and the only thing you can be absolutely sure about is the fact that you feel when you're feeling, right? Your memories about 5 minutes ago can't be sure, okay? The only thing you'll be sure of is that whatever it feels like something is happening now, it's happening now. And then that leads to the mind-body problem because that mysterious thing turns out to be non-functional. For all the face of it, we were talking about the fact that we were going to give an explanation over here. We're all headed for an explanation. Well, when the moment for the explanation comes and you say, well, I got into this because of the mind, because of feeling, that's what makes all of this matter. So what's it for? A big blank. Behaviorism didn't give the answer because all it did was sort of describe the phenomena. It's like saying instead of giving a design that will pass the Turing test, you just list the things that people can do if they can pass the Turing test. Doesn't help. And observations don't explain themselves. The reason that Hebb opened the door for cognitive psychobiology is because he opened the door for explanation. Explanation in terms of things that you can't necessarily observe directly. Behaviorists were making, as scientists, though, the most scientific scientists were the behaviorists, saying the scientific way of explaining behavior, blah, blah, blah. In the end, in their scientific way, they ruled out everything that was explanatory, and they only allowed, because they had a rather simple-minded idea of what science was, they only allowed observations and then sort of lists. Yeah. Go ahead, if it's a quick one.
No, it's not quick.
Uh-oh, okay. Okay, yes. That's right. This is distributed cognition. So Hebb allowed us to theorize about unobservables. He gave us his cell assembly and countless other things, including the stuff that led to the sensory deprivation experiments because of theoretical interest he had and not because he was building a torture chamber. And neuroscience was another, this is our old disagreement with Marley, neuroscience is another, Hebb said it was another potential avenue of explanation. It's not just cognitive explanation, some of it is neuroscientific. And I think that's fine, except that I'm struck constantly by how little we've learned. Now you know I can tell it to you in present-day language, how little T4 has taught us about how to pass T3, you know? Artificial intelligence, you know, it was the attempt to produce, unlike behaviors, to produce something, anything that can do what the kinds of things we can do. And in the end, it led to robots. And the idea is that the explanation of how to do it will be the explanation of cognition, at least the part of cognition that leaves out the hard problem, which is why is it that any of that stuff is felt. We talked a lot about causation, and it's a causal explanation we're looking for, and in fact it's causality that lets us down when it comes to the hard problem. It's exactly because of causality that we can't explain it in the usual way, because there's no room. Evolution played its role. We talked about it in the Ball-Hughes and Bus session, and it's always in the background because you have to explain why it is that certain cognitive mechanisms were useful, and that led to the distinction between the original environment, the present environment, and how a lot of things that we do now were not designed for what we're using them, designed by evolution, for what we're using them for now, but designed for something that we had in the original environment. We talked about reverse engineering, and the idea that we have, usually we do engineering forward. We build vacuum cleaners in order to have something to suck up the dust. But sometimes there's an organ like the heart, and we don't know how it works, so we don't know how it works, so we try to figure out how it works, and then our test of whether we've done it is often, in the case of the heart, it's not necessarily that, is often to build something that can do what it can do, to show that the principles really work. We talked about Turing, and Turing sort of pervaded the whole course. His basic contribution, besides tons of other things, computation itself, was to say, look, don't overreach. The only thing you can ever explain is doing. Explain the doing. The explanation of the doing is the explanation of intelligence, cognition, or whatever it is you want to call it. And that's all you're going to find out. So don't fret about questions that won't answer, because you can't answer those questions. He was basically right. Searle's Chinese room argument to show that Turing was right, but the interpretation of Turing that said he meant computation only is wrong. Searle, the Turing test, of course, is not just T2, but T3 and T4. You understand that now. In fact, there it is, the Turing test. Here we have a robot passing T2, but he's passing, and in my view, the only reason he can pass T2 is because he has the capacity to pass T3 as well. You're not testing it, but he has to have the ability for grounding. What about the brain? Well, what about the brain? It's certainly doing the job. As far as a hard problem is concerned, it's certainly the brain that's causing our ability to do, and it's certainly our, I don't know, by the way, I'm not a spook, I'm not a dualist. I know it turns out we have mystics in the room, but I really do think that the brain, in some sense of causes feelings. It's just puzzling to me that we can't explain how or why. But surely it's that, it's not something on planet Neptune. I will stop. Well, now I'm offline again, doing it the way I hate to do it. The symbol grounding problem was taking the question of if computation is not grounded, and as Searle has shown, cognition can't be just computation. There's also dynamics. The question is, how can you ground the symbols? Computation is just symbol manipulation. Language is symbol manipulation. How do you connect the symbols in computation, or the words in language, to the things that they refer to in the world? And the suggestion is that you do it by sensory motor grounding. You learn to categorize things. Your brain does things for you. It picks out the features that distinguish the members of the category from the non-members, the so-called positive instances from the negative instances. And remember also the special problem of Chomsky, where it's the positive instances and the negative instances of universal grammar, where this doesn't work, because you never learn it. But for ordinary categories, cats, dogs, colors, and all of the things that we see, hear, smell, taste, and eventually talk about, we learn what's in them, and we learn what's not in them, using our senses and our interactions with the objects. Our brains, mysteriously, but we have to explain it eventually, pick out the features that tell apart the members from the non-members, and then using that, because of language, we can recombine them into propositions that define or describe new categories, categories that we didn't have to learn by trial and error because someone else had already learned them by trial and error, or figured them out in their minds, and they just tell us in words. I got ahead of myself in what I was saying. I'm just repeating now that in the session on categorization and cognition, we focused on how it is that we learn to do what needs to be done with whatever it needs to be done with, and that's categorization. And it's not the only thing in cognition. There's also continuous skills like swimming and dancing and walking and what have you. But every skill that involves all or none decisions as to what to do now is categorization. Discrete decisions. That's why it's digital rather than continuous. And for that, you need category detectors. Those category detectors, some of them are inborn. They're in our brains when we're born, but most of them are learned. If you open up a dictionary or encyclopedia and look at words, they're the names of categories, and then ask yourself, is it likely that I had an inborn detector for this? And if you're not Jerry Fodor, the answer will be no for most of the things that you see in a dictionary and encyclopedia. You had to learn them, and you learn them by category learning. We talked about evolution and cognition first in a very general sense. There are some evolutionary modules or mechanisms, specialized behaviors or specialized, well, we know about specialized structures like wings and legs, but there are also in the brain specialized behavioral mechanisms like the ones that are related to our fear of spiders and our fear of heights that were useful to our ancestors. So in the same way that children have a sweet tooth because getting sugar, which gives you the energy to escape from predators, was important, and the children that didn't have a particular craving for sugar and ignored the available sugar when they had it were more likely to be eaten by a predator. I'm simplifying, but that's the kind of story they tell you in evolutionary psychology. Well, in the same way, these other mechanisms like fear of spiders, sexual mechanisms like jealousy, detecting infidelity, and so on. These things probably had, if you look those up in a dictionary, they probably do have, or an encyclopedia, they probably do have an inborn mechanism. If it's not exactly category detection, because the genes don't like, as I said, to code things too fully when a lot of it is predictable from experience, there's a strong tendency. For example, if it's not true that we have a spider template built into our brains, the minute we see something with 8 legs like that, we shriek. But there's a tendency to learn, to avoid, and to escape from things that look like that very quickly. That would be Baldwinian evolution of a spider fear. Maybe in the case of spiders, it's actually built in already. I don't know. But in the case of, for example, ducks that are imprinting on the first moving object when they're born, it's not that the duck shape is built into their detectors. They simply sample, and the first thing they're likely to see moving when they're after they're hatched is their mother. If it's a predator, they're cooked anyway. So if it's their mother, then they have this strong tendency to follow the mother, and then they learn that that's the shape that, for example, when they grow up and become mature, that's the shape that they should want to mate with. If they happen to imprint on human beings, then they're going to be sexually interested in human beings when they grow up. That just goes to show you that the shape of the kind of thing ducks are interested in sexually is not built into them, or not completely built into them. It's just a mechanism that uses the predictable early exposure to a moving mother to teach them which kind of shape is their own kind's shape, and then later on that becomes what they're interested in sexually. It might be the same way with spiders, but the whole point with evolution is that there are these spiders and these sexual things, but they're a minority. What most of the stuff that we were talking about in this course, most of the categories that were involved are not categories that were prepared mechanisms for either detecting innately or quickly learning to detect by Baldwinian evolution. A lot of things are just a general capacity to categorize. And that general capacity to learn to categorize pervades cognition. If you want to treat the ability to categorize as being like spider phobia, that's fine. But all of the categories that we actually learn, all those things in our dictionaries and encyclopedias, are learned using that mechanism. The evolutionary basis is just for the ability to learn the categories and not for the categories themselves. And that is actually a trivial but important distinction to make when you're thinking about what's innate and what's learned. Language is perhaps the most remarkable and unique and powerful thing that we ever evolved. There's lots of open questions about it, as you recall. We don't know what it is that took us from the understandable and capacity to mimic and to point, which although we have it more than other great apes, for example, nevertheless is not language. What's language is the capacity to categorize, which we also share with the apes, by the way, but to categorize things and then assign an arbitrary name to the category, agree on an arbitrary name to the category, and be able to make propositions that combine those names so as to define and describe new categories. That's the remarkable ability that we have that no other animal has. No matter how hard we train them, they don't have it. And some of the questions about that are difficult to answer. They're easy questions in the sense of the easy problem and the hard problem, but they're still difficult to answer because the evolutionary origin of language was way back 300,000 or more years ago, and it didn't leave any traces, so it's all really speculation and simulation that we have available. But some of the speculation is perhaps more credible than other speculation. It might even turn out to be right. One part of the evolution of language, however, and that's the evolution of universal grammar, the syntactic rules, the rules about what's well-formed and badly formed, that all languages seem to share and that are quite complicated, and that we didn't know before Chomsky, and that most of us still don't know now, because they're not explicit knowledge. They're something that our brains know how to do, but we don't really know the rules. Well, that's nothing new. There's lots of stuff in cognition that our brains know how to do, but we don't know the rules. But in the case of learned skills, it's learning that explains how our brain knew it. In the case of inborn skills, it's usually evolution that explains it. Well, in the case of universal grammar, the way we can tell apart sentences that are that conform to the rules of universal grammar and sentences that don't, sentences that are well formed and sentences that are not well formed, the way we can tell them apart is by having the rules somehow in our heads, but we don't know what they are, so we don't do it by consciously applying the rules, and we didn't learn them. We couldn't have learned them, because it turns out that all of the examples that we encounter of things that are well, of strings of sentences in languages, they're all conforming to universal grammar. We only hear positive instances, members of the category of sentences that are obey the rules of universal grammar. We don't hear and we don't say, children don't hear and don't say, adult linguists sometimes do because they're working on it, but children, when they're learning language, neither hear nor say, therefore don't get corrected on sentences that are not compliant with universal grammar. They only hear positive instances, not negative instances. They only sample what's in the category and not what's not in the category. That means that the category detector, the thing that distinguishes what is and isn't UG compliant, that means conforming to the rules of UG, must already be built into their brains. And that's an especially hard, if you like, easy problem. It's a hard, easy problem of evolution because the usual evolutionary explanation doesn't explain why we would have evolved universal grammar. It's easy to explain why we have eyes and hearts and lungs because they all confer advantages for our ancestors in surviving and reproducing. Is universal grammar something that confers advantage? Language certainly does. But universal grammar, because it's complicated and because logically speaking, other grammars that are not compliant with universal grammar that linguists have since invented would have worked just as well, or at least would have worked just as well if the hypothesis I gave you about the origins of language is correct. Namely, if all language was for, or what language was mainly for, was to be able to make propositions that allow us to define and describe new categories, we could do that not only with other grammars than universal grammar, but even with much simpler grammars than universal grammar. And yet we have universal grammar. It's exception-free. It's in all of us. How did it get there? Why did it get there? It's a hard problem. It's not a hard problem. It's a hard, easy problem. It's not a hard problem like consciousness, but it's a tough one in its own right. I have no answers. The real hard problem, though, is how and why do we feel? One of the things to remember is that all of the weasel words, all of the synonyms for consciousness, like intentionality, subjectivity, first-person point of view, all of these awareness, all of these things are just delaying facing the hard problem. Throw them all away. Even mind and mental, you don't need all of those words. All you have to say, and the Kid Sibley way to say it is, there's a weird thing about earthlings, humans, probably also other animals, which is that that not only do they do what they do and survive and reproduce, so the Darwin story is perfectly fine. What they do because, what they're able to do, they do because it was useful to their ancestors to be able to do that in surviving and reproducing. That's not the problem. But the question is, while they're doing all of that stuff, they're also feeling something. And the question is, why? How is it, part of the hard problem is how does the brain feel? But let's put that aside. I have no doubts about the fact that somehow it's the brain that causes us to feel. It's just that it's quite natural to ask how does the brain cause us to feel? And more important, here it's really more important to ask why. This is a functional why. What functional, causal role does feeling play in all of the stuff that we can do? T3 and T4 turn out to be just the same, whether or not we feel. They're all about doing. So the hard problem, and in my opinion, the insoluble problem, is accounting for how and why we feel causally. The reason it's so hard is because psychokinesis, which would be a perfectly good explanation, there's an extra causal force in the universe, just like gravitation and electromagnetism, and that's the feeling force, the force of feeling. And when I do something because I feel like it voluntarily, deliberately, etc., the feeling force is involved. So things that lack the feeling force, I don't do. But the trouble is there is no feeling force. All of the stuff that I do is explainable in the usual way by T3, T4, which means by computation and dynamics. So why is it felt? How is it felt? That's the hard problem. It's a gap, and I think it's a gap in explanation. I don't really think it's a gap in the causal process, whatever it is. It just means that our ability to explain things causally seems to run aground when it comes to explaining how and why we feel. It works for everything else. It doesn't work for that. I can't tell you why, except that there's no room for psychokinesis, so that's false. And, pardon me, psychokinesis is false, and if psychokinesis is false, which it is, there's no room for any more cause. The other forces take care of everything else. There's nothing left for feeling as a functional role, which means it's there, but it has no function, or at least we can't explain its function, and that's the hard problem. This is the last lecture. I just wanted to suggest that you shouldn't substitute this sort of quick, breathless KidSib summary that I'm giving for rereading the readings, the relevant parts of the readings for the course and the sky writings, because this really is a synopsis, and what you should be preparing to give me in the exam to show that you've mastered it is something other than this breathless synopsis of mine. But just to remind you of what's at issue with the extended mind, what makes a mental state mental is that it's felt. Clark and Chalmers sort of equivocate. They fudge this thing. They talk about beliefs, and they don't particularly emphasize whether, or put any emphasis on whether the belief state is actually being felt, or it's just sort of belief that's stored someplace. Well, when it comes to storage, yes, it doesn't make any difference whether storage of data, of facts, is outside the brain or inside the brain. We were talking in class about the fact that you could remove perhaps parts of your memory system, and you would still be a mind. There would still be a mind there, and you would still be in felt states. In fact, if you lost the internal datum for, let's say, who wrote a certain book, you can look it up in Google, and you've got it again. And again, you're in that felt state of knowing who wrote the book. But Google is not part of that felt state. And that's the point. Your brain, a felt state can't be wider than your head any more than a headache can be wider than a head. It doesn't even necessarily include everything that's going on in your head. It includes whatever dynamic activity corresponds to feeling a headache, and that's it. And that doesn't go wider than the head. But on the other hand, there are lots of things that do go wider than the head, and they're very useful. Not only in exactly the same way that telescopes and microscopes and glasses and cars and planes extend our capacity to see, to walk, etc. Those are all functional capacities and cognitive capacities, and they're extended by various kinds of tools. In the same way, the World Wide Web and Wikipedia and Google extend our capacity to remember or to acquire information. In some ways, they're similar to, they're an extension of language, because when Google tells me something, right, it could have been my fellow Paleolithic creature that told me those things. It's the fact that it's written or spoken is irrelevant, or gestured. We all know it's irrelevant. And the fact that it's coming from a book is simply, in the past, was somebody wrote it in the book. Well, somebody put it into Google. Or a computer program gathered it. Nobody even put it in. It doesn't matter. My capacity for language makes it possible for me to extend my capacities to do through the categories that I acquire via language and via the web. It's an extension of my capacities, but mental states, being felt states, are just in my head. The tools that I use in exercising my capacities can be outside my head, of course. The tools literally are outside your head, but they're not part of your mental states. This is the overview is what I just gave over here. And I wanted to close by saying that I hope that it's not just some of the ideas from the course that will stay with you for the rest of your life, but also the idea of skywriting like this. It's a way of interacting with the ideas that I think is unlike anything that came before. It's not as dramatic as the evolution of language, but I think it's perhaps as revolutionary as the invention of writing and printing. What it needs to do is catch on. Bye-bye.